Welcome to the video tutorial for acids and bases. This is going over pages 3 and 4 in your homework. Please make sure if you were absent today that you are first looking at the notes on Canvas, otherwise you're not going to really understand what's going on here. So we're saying A for acid, B for base, or C for both. And we learned in class that you have a bitter, blue, base. Okay, that's kind of a little memory device for you. So sour would be acids, bitter is going to be our base, and electrolytes, that'd be both of them. Acids and bases both dissociate, so they can conduct electricity in a solution. If we skip down to number 6, a substance which turns blue litmus paper red or causes red not to change. So that would be acids. Turns red blue or makes blue stay blue, that's a bitter blue base. Okay, so if we remember bitter blue base, then we know that acids must be the red kind for those litmus papers. This is a day 1 review, naming and writing formulas for acids and bases. But let's take a look at it. Aluminum hydroxide. To write a formula, that's a 4-step formula. I'm going to say aluminum and hydroxide. Aluminum is right here in the exception block. Okay, so it's one of the 3 and 3A that always makes a +3 charge. So we'll say aluminum making a 3 charge, and hydroxide on the polyatomic ion list is the 1. So I crisscross around the parentheses. The formula for this base would be AlOH3. Naming this one, I see 1, 2, 3 capital letters. So I know this is not a binary acid, it's a trinary or tertiary acid. So I'm not going to call this hydro. I cannot use the prefix hydro. I know it's an acid because it starts with an H, so I'm going to end with acid. Okay, and then I need to look at SO4, which is a polyatomic ion. SO4 is sulfate, so our little mnemonic device for remembering sulfate is I ate too much, I feel icky now. Okay, so instead of sulfate acid, we're going to call it sulfic acid, or in this case, sulfuric acid. Okay, this is the weird extra letter one, so if you said sulfic acid, we wouldn't really count you wrong. We're supposed to remember this in sulfuric acid. Okay, looking here, naming this one, I know it's a base because it ends in OH, and so bases we just name as normal ionic compounds. Iron hydroxide, but you'll have to remember that iron as a transition metal has to have a Roman numeral. So I'm going to call it iron blank hydroxide. So to know what charge this iron is making, I have to look back here. Hydroxide we know makes a 1 charge, and that's why there's an invisible 1 there. So this iron must be making a 2 charge, and that's why there's a 2 back here. So I'm going to call this iron 2 hydroxide. Looking at this one's different from my other acid. I know it's an acid because it starts with a H, A-C-I-D. There we go, acid. But there's only 2 capital letters. There's only 2 elements, which makes it a binary acid. And all binary acids start with hydro. So hydro means there's no polyatomic. So instead of bromine, we'd call it bromic acid. Hydrobromic acid, like this. All right, down here at the bottom, we're labeling as acid or base. Which one, we're looking at these, are acids or bases. So if I look in here, I see the H plus and the H3O plus. That tells me it's an acid. Okay, having more OH ions released, that's a base. Okay, H plus or H3O plus, that's acid. And then more hydroxide or OH ions is a base. Now you really do need to know that the pH scale goes from 0 to 7 to 14. So this is where we're perfectly neutral at 7. Anywhere down here are my acids. Anywhere up here would be base. Okay, so a pH of 14 is definitely going to be a very strong base. pH of 12 is base. pH of 4, acid. Acid. And a pH of 1 would be a very strong, very dangerous acid there as well. Okay, so that's how we should be doing this based on what we learned today in class. Let's look at page 4. A couple things on page 4. On day 1, we learned about Arrhenius acids. Arrhenius, just the typical class acid, produces hydrogen ions, okay, and bases make hydroxide ions. So we learned day one, acid starts with an H and bases end with OH, and that's true. But there's a more broad definition, that's the Bronsted-Lowry. So Bronsted-Lowry is less specific, I suppose. It defines bases as proton acceptors, and acids are anything that donate protons, so proton donors. Okay, just like here, acids produce H+, that is a proton. So Iranian says acids make H+, Bronsted-Lowry says acids make protons. It's the same thing. Okay. Looking at acid, base, or neutral here, sour would be acids because bases are bitter. Pure water should be neutral. Releases OH, so makes more hydroxide ions, that would be a base. Turns red litmus paper blue, that's a bitter blue base. Okay. The H+ concentration is less than the OH. So I have less acid than base, which means I'd be a base. pH greater than 7, so a pH over 7 is also a base. Proton acceptor, that's right up here. Proton acceptor, so we'd say that's a base. And turns blue litmus paper red, that'd be the opposite of this one, so we'd say acid. Looking down here, you're using this to fill in these ones. So milk, it says on here, has a pH of about 6. An antacid has a pH of about 10. And orange juice here has a pH of about 4. How we read this is we use the absolute value of the exponent, and that's how you do the log with the base 10. So in this case, instead of -2, it's just 2. Instead of -8, it's just 8. Instead of -5, it's just 5. So a pH of 2 is an acid, pH of 8 is a base, pH of 5 will be an acid, like that. Okay, so that's what we worked on day 2. Good job.